Hello everyone, today I'm going to be going through every single final question in all the past papers that you have for AQA GCSE Maths Higher. So I'm going to do this live so that you actually can see my thought process, and let's just get straight into it. There is a worksheet of all these questions compiled. If you want to have a go yourself, in the description box, you can access it with your school email. Okay, so first of all, we have y equals x squared, a normal quadratic. So for it to be transformed to go up 2, we're going to add 2 in the end. So it's just normal graph transformation. You can put in x equals 0 to test that it's going to be at 2. You can put in other values if you want to test, but it's going to be correct. And just be careful that you remember your y equals, because if you only put x squared plus 2, you don't get the marks. Okay, this graph is being reflected by the x-axis, so you're just going to put a minus before it. You just have to know that that's it. And then finally, when it's moving to the right 3, it is opposite of what you would think it does. Because when you're going positive 3, you think you're going to add. But no, you're actually going to minus 3 because it's weird. And then that would be your final answer. You will replace x with x minus 3, and this will shift it to the right. Again, you can put in some values to test, but that's about it. Okay, the next paper, which is a horrible question because this is the kind of things that you do not want to get in a real exam because you need to think. So basically we have two of the same rectangles and we want to find we want to prove that GD splits ADF into two perfect halves. That's what bisects mean. So first of all, here I can see an alternate angles here, which means this angle will also be x. So I'm just going to mark that down. This angle will be x. And then we have an isosceles triangle here because they are both lengths of the rectangle, which means because that's the length of a rectangle, that's the length of the rectangle, these two are the same, they're isosceles, which means the two base angles here are going to be the same. So what I can do is I can say let me put the equation down here. I can say that angle ADG is equal to 180 minus x over divided by 2. Because 180 is the angle sum of triangle, minus x gives me the sum of these two angles, and then divide by 2, I get one angle. And I can simplify that into 90 minus x over 2. Brilliant. Now all I need to work out is GDF and prove that they're equal to each other. And the way I can do that is I can say GDF is equal to, because this is on a straight line, so I can say a straight line adds up to 180, minus x, and then minus bracket 90 minus x over 2, because this is, basically this is this angle, and then x is that, and 180 is everything. And you need the brackets, they're very important because you need to distribute the minus. That's where most people lose their marks, because minus minus here gives a positive. So here I'm going to rearrange the order to get this, so that is easier to see. So I get 90 minus x plus x over 2. And this will be equal to 90 minus 2x over 2, because that's what x is, plus x over 2. And then finally, I think we can see that we have minus 2 of that and then plus 1 of that. So we get minus 1 of that to get this. And I can say, because angle ADG is equal to the angle of GDF, and I can write therefore GD bisects angle ADF, and that will be done. Very difficult question for 4 marks. Just hope that that doesn't come up in the real exam. Okay, next we have a curve and we have a straight line, and we want to find 2 points of intersection. Now, when we have a system of simultaneous equations, so when we have two simultaneous equations, if you plot it on a graph, where they intersect is the solution to that simultaneous equation. Which means, to go backwards on that logic, if I find the solution to the simultaneous equation, then I can find the 2 points of intersection. So what I'm going to do is I'm just going to say these two, I'm going to try to solve the simultaneous equation of these two. Now, because they're both equal to y, I can just set them equal to each other. So I get this equals 3x minus 2. Let me make this a little bit bigger. So we get this. If I add not add, if I minus 3x on both sides, and then plus 2 on both sides, I get this quadratic, which I can factorize by finding two numbers that add to 1 and multiply to minus 2. And I think that combination will be plus 2 and minus 1. And then we can solve this, so we get x equals 2 or, nope, x equals minus 2 or x equals 1. And the final step to find the 2 points of intersection is to put this back into one of the equations to find y. Now, I would make my life easier by putting it into the second equation because it's a lot easier. So when x equals minus 2, that's minus 6. Minus 2 is minus 8, so I get this. And then the other y, where I put in 1, will get 3 minus 2, which is 1. And then finally, you need to pair them up correctly to get the final marks. So the points would be points of intersection at minus 2, minus 8, pair them up correctly, and 1, 1. And that will be 5 marks. Brilliant. Next, show that the value of this is an integer. So this is basically, do you know your exact values? Now, I always recommend you to remember your entire exact values table. So for sine 30, it is equal to a half. And then for cos 30, it is equal to root 3 over 2. So I'm going to put root 3 here, root 3 over 2. And then and then we're multiplying. So hold on, multiply. We're multiplying. Oh, does that not work? Oh, I think the shortcut is times. Okay. Times 4, tan of 30 is 1 over root 3. So I'm going to put it like that. And we just need to show that this simplifies to an integer. So 6 times a half is 3. This 2 and that 2 will cancel out to give me root 3. Yes, to give me root 3, but they are multiplying, so I'm going to make sure that I know my bottomers. So here, and then times, and then this is 4 over root 3, because we're timesing the top by the top and the denominator by the denominator. So we get this. Now this will simplify because root 3 and root 3 cancels like that, so I just get 4 is 7, and it's an integer, and we're done. Brilliant. 4 marks for remembering your value, so it's actually really good. Next, we have a right-angled triangular prism. By the way, I have not seen these questions before. I only saw them very briefly when I pasted the screenshot into the PowerPoint. So I just hope that you can see how I'm thinking through stuff. Okay, so the ratio of the edges of A to B to C to D is 3, 4, 5, 12. Okay, and the volume is 1, 1, 2, 5. Okay, so a ratio is demonstrating how the lengths interact with each other in terms of their mathematical properties. I made that way more complicated than it needs to be. Basically, what I'm saying is, what if I just say A equals 3k, B equals 4k, and then C equals 5k, and then D equals 12k, because that's what the ratios means, right? They are a common multiplier of each other. Then I can find k by saying that, by finding the volume of the prism in terms of k. So, a volume of a prism is the base area times height. So the base area here is A times B divided by 2. So I have AB divided by 2. Let me make this a little bigger, because that's the area of the triangle, and then times D. So I have ABD divided by 2. And that is equal to 1125 apparently. So if I multiply the 2 to the other side, so I get 2250. And then I think what I can do is I can say ABD equals 2250, and I established that A is 3k, and then we have B being 4k, and then we have D being 12k, and that's equal to 2250, which means I have 3 times 4 is 12, 12 times 12 is 144, and I have 144k cubed equals 2250. Now, because this is a paper 2, I'm allowed a calculator, so I'm going to type in 2250 divided by 144, which gives me 125 over 8. So k cubed equals 125 over 8. If I cube root top and bottom, I get 5 over 2 being k, which means I can find a. If I times it by 3, I get 15 divided by 2, I get 7.5. B, I get 4 times 5 is 20, divided by 2 is 10. And then C is 5k, so I get 25 over 2, which is 12.5. Finally, D, I get 60 divided by 2, that's 30. And the question asks for the length of all the edges. So all the edges will be A plus B plus C. So I'm going to do A plus B plus C, which is 30. And I need to times it by 2 because I have 2 copies of them because of the uh base. And then I have 2 D's here. So I'm going to plus 2 D's, so another 30 times 2. And then just make sure that you're not missing out anything. Oh, I missed out 1D up here because there's actually a length here as well. So it's 30 times 3. I believe that would be 60 plus 90, which gives me 150. And we need to give the unit. So the volume is in centimeters cubed, so this will be in centimeters because it's the length of all the edges. So that will be the answer. Great, 5 marks. Next. So I put 2 questions here because question 23 is something that they want to trip you up on. So we have quadrilateral ABCD is reflected in the edge BC. How many of the vertices are invariant? So the word invariant is what they try to use to throw you off. It simply means it doesn't change, right? So because variant is changing and invariant doesn't change. So what we can do is to just, it doesn't specify what quadrilateral it is. So I can just draw any one I like. I'm going to draw a square. So this is ABCD. Trust me, it's a square. Trust. And then it's being reflected in the edge BC. So if I reflect it here, I get a quadrilateral like this. So BC doesn't change, which means there are 2 points that doesn't change. Brilliant. And then finally, we have a complete the square for a quadratic. So the way we do that is that we do not want an A term. So we're going to factorize out the A term here. So I can get this, and I'm going to leave the C term like that. So if you distribute this out, you still get 2x squared minus 12x. Now this, we need to complete the square for what is inside. So the way you do that is that you halve the B term, you halve this. So minus 6 becomes minus 3, you square it, and then think about what minus 3 all squared gives you. Minus 3 all squared gives you 9. So you want to take away 9 to get rid of it, and then don't forget the plus 7 in the end here. So what this gives me is, it gives me 2x minus 3 all squared, and then 2 times minus 9 here is minus 18, and then plus 7. So finally, this will give me 2 times x minus 3 all squared, and then minus 18 plus 7 is minus 11, and this is in that form that they want. Brilliant. Next, so we have sine graph, cos graph, and tan graph, and we want to take the statement that is true. So what I'm going to do is I'm just going to sketch it. So to sketch the graph, we have, oops, let me get my pen out. There we go. So the sine graph looks like this. Whoop, between 0, 180, and 360. The cos graph looks like this, between 0, 180, and 360. And the tan graph is the weirdest one because it looks like, what does the tan graph look like? That's a good question. Tan 0 is 0, so it's going to be this. And then there's an asymptote here, and it goes here. And I think that's 360. No, that's 180. Yes, that's 180. So I actually need to draw one more because it goes up to here at 270, and then 360 ends here. Cool. So that's sine, cos, and tan. So y equals sine x passes through 180 minus 1. Okay, so here is 0. This is 90. This is 180. So it is not at minus 1. At 180 is 0. So this is not correct. Cos x passes through 180 minus 1. So that's 0. And then that's 90. And then this is 180. And then this is 270. And then that's 360. So does it pass through minus 1 at 180? Yes, it does. So this will be correct. Next, y equals sin x passes through 271. So here is 270. It's actually 270 minus 1 because it's down here. So this cannot be correct. And then cos at 270 here is at 0. So this is not correct either. For tan, this is a bit more tricky. So this is 90, this is 180, this is 270. At 270 is undefined, so it's not going to be this. Therefore, none of the graph passed through 271. Brilliant. Next. So here we have, I think this is, this is product rule of counting. So a code is 3 letters. I'm going to draw 3 lines, 3 letters, each of which is in the word logic. Vinny assumes that letters in a code may be used more than once. He works out how many possible codes there are. In fact, the first 2 letters are the same and the third is different. How many of Vinny's codes are not possible? Okay. So first of all, how many possible codes did Vinny find? So the letters in the code may be used more than once, which means there are allowed repeats, which means it's going to be 5. There are 5 options for the first one because of logic. There's 5 options for here, and 5 options for here because we have 5 letters for logic. You can times all the options together to tell you how many total options you have, which is 125. Now, for the actual rule is that the first 2 letters are the same. So we have 5 options for this, and then we only have 1 option for this because it must be the same. And then finally, the third is different, so we have 4 options for this, which means there are actually 20 possible codes. So how many are not possible is 120 minus 20, 125 minus 20, so 105 is your answer here. 105 is your answer. Brilliant. Next, the graph y equals x cubed is translated to this. Write down the translation vector. So here, again, remember how when it's inside the function, it actually does the counterintuitive thing. So minus 2, you expect it to go left, but it actually goes right. So when it's going right 2, the translation vector will be 2, 0, because we are increasing x by 2, and then y doesn't change. Okay, and then we have y equals 5x plus 4 reflected by the y-axis. So when you're reflecting by the y-axis, only the x changes. So you get 5 times minus x, only the x is minus, not the entire thing. So you actually get minus 5x plus 4. So this will be your answer. Brilliant. Next. Show that the average speed of the whole journey in kilometers per hour is this. Okay, so some algebra here. So first of all, we need to know that speed equals distance over time. There we go. Technically is velocity, and then technically is displacement. I'm not going to get into that. Anyways, because s is technically displacement, so it doesn't, just hate the notation of GCSE. Okay, so speed equals distance over time. So we want to find the speed, which is great. So for the whole journey, we want to find the total distance. So the total distance will be 30 plus 30 because of the 2 stages. So it'll be 60. And then divide by time will be this plus that. So it's 30 over A plus 30 over B. Now, do not panic when you see composite fractions like this, because they're not that bad. So first of all, what I'm going to do is I'm going to combine them. So I get 60 over. If you think about having the same denominator here, I get AB, and I get 30B plus 30A. And then what I'm going to do is I'm going to multiply the numerator and the denominator by AB. So that this cancels out, so I get 60AB divided by 30B plus 30A. Then finally, 60 and 30 cancels out to be 2, and I can swap the A and B, and that is what the question wants, and that is the answer. Brilliant. All right, another algebra fraction question. So actually, if you get really good at your algebra, you can get so many marks in the exam. So if you don't know what to work on your algebra. It makes up so many, such a big portion of your exam. Okay, show that this simplifies to that. Okay, first of all, I'm gonna get the same denominator, so I'm going to multiply the denominators together. The top will be multiplied by this because this is times that, so that must be times that. That was incredible explanation, by the way. This will times that, and that will times that. And then this will times that, and that will times that. Cool. Okay, we got this. And then all we need to do is to expand this. So, this will give me x squared minus 5x, and then plus 2x. So that's minus 3x, and then minus 10. And then we're adding another x squared, and then here minus 2x plus 5x is plus 3x, and then here is minus 10. And then down here you see a difference of two squares, which is when you have a squared minus b squared is equal to a plus b times a minus b. So in this case, a will be x, b will be 2. So this is actually a squared minus b squared, like that. Finally, we just need to clean up what is happening in the numerator. So x squared plus x squared is 2x squared. Minus 3x plus 3x cancels out, and then minus 10 is minus 20. And that will be our final answer, which is in this exact form. Brilliant! Next, bearings. Horrible. They are unbearable. Haha. Sorry. Okay, so a boat sails 35 kilometers north from A to B, like that. Cool. From B, the boat sails to C and then back to A. So I want to show the distance the boat sails from C to A is 79. So I want to find this distance. Right, first of all, I get 35 and I get 65 here. And because I get this to be 80 degrees, I know this will be 100 degrees. So because this is 100 degrees, I can use the cosine rule, which is, depending on how you learn it, you might learn different, it doesn't matter. But I think on the formula sheet, they give you a squared equals, what do they give you on the formula sheet? I actually don't know. They give you a squared equals b squared plus c squared, take away 2bc cos a, I think, is what you get. Something along these lines. So in this case, I have cos a to be 100, so which means this length would be my a. So I'm going to say the unknown length, a squared here, which is the length I'm trying to find, is equal to b squared, so 65 squared, plus 35 squared, and then squared, and then take away 2 times b, 65, times c, 35, and then cos 100 degrees. Is going off the screen, so let me fix that. And yeah, so a squared, if I type that into my calculator, I would get, let me just very quickly do that, plus 35 squared minus 2 times 65 times 35 times cos of 100. By the way, when you go into your calculator exam, remember to check whether your calculator is in the correct mode, whether it's in degrees mode or not. Because, I'm not going to say who, but in our school there's a very common prank going on. People find it funny to steal someone's calculator and then change it into radians mode so that they can screw up all your answers. So remember that you do not fall prey to that horrible scam, and to check your calculator mode before you enter the exam hall. So yeah, when you square root, you get a equals 79, which is correct. And that will be my working. That's 2 marks. How on earth is that 2 marks? Am I going crazy? There must have been some easier way to do this that I didn't see. Anyways. Okay, here, work out the bearing of A from C. Okay, so we know that this angle will be 100 degrees because of co-interior angles from year 9. So because these two are parallel, they must add up to 180. So 180 take away 80, this is 100. And then 360 minus 100 will give me this angle plus this angle. So I actually need to work out what this angle is. So this little angle here, I need to work out what this is. If I know this is 79 to the nearest degree, not degree, to the nearest kilometer, then I can use sine rule here, I think, which is sine A over A, or A over sine A equals basically A over sine A equals B over sine B. So here I have 79 over sine 100 equals 35 over sine whatever. I don't know what that is, so I'm going to call it sine C because it is at the angle C. So what I can do is I can multiply this over and multiply that over. So I can cross multiply to get 79 sine C equals 35 sine 100. And then I can say sine C is equal to 35 sine 100 divided by 79. And I can just type all that into my calculator with my sine inverse so that I can get C. So the sine inverse of 35 sine 100, let me just quickly do that. Sine 100 divided by 79 gives me 25.87 to 2 decimals place. The C equals 25.87, which means the bearing will be 260, take away that. So bearing equals 260, take away 25.97, which is equal to 234. Is that right? 234. Let me just make sure that I'm not getting. Oh, it's 25.87. Sorry. I just copied that wrong. And then 234.13 is our answer. But actually, bearing only needs two numbers, so I'm going to say 234. So the nearest integer. Cool. So the bearing is 234 degrees. Brilliant. Nobody likes bearing questions. Next. So we need to work out this thing and give it in this form. Not too bad. So first of all, the first thing I'm going to do is I'm going to put this into what a sane person would do, which is improper fractions. So 16 times 2 is 32, plus 13 gives me 45. And then this is being minus 2 over root 5. Now, when I square root this, I can square root the top and the bottom together. So I get root 45 all over 4 minus, and I'm going to rationalize this. So I can rationalize this by timesing top and bottom by root 5. The reason is if I do that, this becomes 5 because root 5 times root 5 is 5, and this becomes 2 root 5. And this is helpful because we can combine stuff together. So first of all, I'm going to say that root 45 is actually square root of 9 times the square root of 5, right? So this is actually just 3 root 5 over 4 minus 2 root 5 over 9. 2 root 5 over 5, sorry. So now I can get a common denominator, multiply this upwards by 5, and then minus 8 root 5 here. And then finally, this will give me 7 root 5 all over 20, and it is in the form that they want, and that will be correct. Brilliant. Next. So for this question, it's some 3D stuff. So let's have a look. So first of all, EB, which is this length, is 29. Okay. And then EBP, so this angle is 35. And then EPB, this is 114. I want to work out EP. Okay, so it's a load of yap, but actually it's just a triangle that looks like this with EB. So EB is here and then P is up there. So EB is 29 and then EBP, this is 35 and then EPB, this is 114. And they want to find what this length is. So the entire 3D shape is useless. They're just here to throw you off. Great. So we have this. So we can use sine rule again. So 29 divided by sine 114 is equal to, I'm not going to say question mark, I'm going to say x, divided by sine 35. So if I multiply it over to get 29 sine 35 over sine 114, that will give me x, and that will be my length. So if I type it into my calculator real quick, again, make sure that your calculator is in degrees mode, and then you get sine 114, boop. So you get 18.2 to one decimal place, and then this is in centimeters. Always give your unit because this is in centimeters. Brilliant. Oh, this one is a horrible question. I remember pasting this question in, and I was like quickly looking through it, and I just saw a horrible trick in this question. See if you can spot it before I explain it. All right, so two sides of a triangle are measured to one decimal place. The angle between the sides is measured to the nearest degree. Work out the upper bound for the area of the triangle. Okay, so first of all, area is equal to half AB sine C, where AB is the two sides and C is the angle in between. So the area of this will be equal to half, and now we need to think. A is here. We want the biggest area possible, which means I need to take the upper bound of this length at the nearest degree, 7.25. Then, for this length, same logic, I need to take the upper bound to get this. But now is where this becomes very treacherous, it becomes very sneaky, it becomes very horrible, which is, what do we do with the sine? So it's in the nearest degree, but if we look at the sine graph, which looks like this is 90 degrees, so 110 is somewhere here. For this to be as great as possible, I actually want it to be smaller. A lot of people will just go 110.5 because it's a bigger angle. But the sine function actually gives a smaller answer for a bigger angle past 90 degrees. So this is extremely sneaky that they want you to see that in a real exam. So actually, you want to take the lower bound of the angle to get 109.5. Now that is absolutely horrendous that they want you to see that. Yes, and that will give you the greatest amount of area, the upper bound of the area. And if I put that into my calculator, 7.25 times 13.65 times sine 109.5, that will give me 46.64 to the nearest two decimal places, and then the area is in centimeters squared, and that is the upper bound of the area. Brilliant. Very horrible question. Okay, another one. These are the marks I really don't want you guys to lose. I really hope that you get all of these because it's just memorizing. So cos 30 is root 3 over 2. Yes. So just make sure that you don't mess this up. Then you're timesing it by sine 45, which is root 2 over 2. And then tan 60 is root 3. So yes. So we have this, and then don't forget the entire square of the entire thing. So we have all of this, and then I'm just gonna click here, all squared. Brilliant. So we're just gonna work out what this is. So we have root 6 over 4, because I can just times that together to get root 6 over 4, multiplied by root 3, and then all squared. And then this will be equal to root 18. So I get root 18 over 4, and then this entire thing is being squared. Now, a lot of you might be tempted to simplify root 18 over 4 because you might see that it is 3 root 2. But we actually don't need to because when I square this, the square root just goes away. So I get 18 over 16. Remember to square the denominator as well, and then you get 9 over 8, which is your final answer here. Brilliant. Next, by complete the square, work out the coordinates of the turning point. Brilliant. If you're in tough set, I'll also challenge you to work out the turning point by differentiating because you also need to know that for further maths. Okay, so complete the square. The first thing we do, we half the b term to get minus 9, and then we think about what minus 9 all squared gives me. That gives me positive 81. So I want to take away 81, and then I need to put the plus 70 in the end. So this is equal to x minus 9 all squared minus 11 because of this and that. And then finally, the turning point is at, we're going to flip this. So minus 9, we're going to flip the sign for that to get 9. So the inner function is being flipped, and then the outer function is kept the same, minus 11. And that will be our answer. So remember, when you complete the square to find turning point, the inside is being flipped, the outside is kept the same. All right. Okay, please, these are very, very free. These are free marks. All you need to do is to be very, very careful and do not mess this up. So yeah, x squared minus 3x minus 4x is minus 7x. And then here you get plus 12. And then you're getting that with x plus 8. And then just be very careful and expand them out. So you get x cubed like that. And then 8x squared. Do it systematically. Do not do it in a weird order. Here you get minus 7x squared. And then here you get minus 56x. And then here you get 12x. And then here you get 96. By the way, it would be very funny if I make a mistake here. And then I'd say that do not make silly mistakes, and I do. Here, minus 7x squared, you get 1. And then here you get minus 44, I believe. Is that right? Yes. And then plus 96, and I think that's it. Brilliant. Next, so a triangle on a grid. Describe a single... okay, because definitely I need to draw this, so let me just draw. A single transformation of the triangle so that point B is invariant, so this doesn't move. Remember, invariant means not moving. Point A goes to 1, 1, so point A goes here. And then point C goes to 1, minus 1, so 1, and then minus 1 is here. So the triangle will look like this. No, that's at minus 2. Hold on, I am actually stupid. Here. So we get this, where this point is A, this is C, and this is B. So we don't want to use one single transformation to describe that. So I think it would be a reflection that that looks like this. Is that right? Yes? Yeah? Is that right? I don't think so. Wait. Because I think if I do that, the reflection will go here. Yeah, so that's not right. So by the way, it's okay to make mistakes. Just make sure that you're double and triple checking in the real exam. So if that's not right, what else can I do? Well, if that doesn't change, what if I rotate it? I use that at the center, and I rotate it by 180 degrees? Is that right? I think so. I think it is right if I rotate it by 180 degrees. Yes, I think it is. So I can say rotation. Now, because I'm going 180 degrees, I don't need to describe what clockwise or anti-clockwise. So I don't need to do that because 180 degrees is the same. Rotation 180 degrees by the point B, which is at minus 1, 1. Minus 1, 1. And that will be correct, I hope so. Brilliant. Next. Work out the value of x. So the flight lasted 2 hours. Okay, so we in total it lasted for 2 hours. So actually I don't really care about what this is, because surely if I add these two up, it's going to be equal to 2. Am I crazy? Yeah. If in total they lasted 2 hours, I don't care about the distance or the speed. So I'm going to say this, let me make this a bit bigger, plus 287 over x minus 24 is equal to 2. That looks good to me. And then, and let me get more space here actually. So here, if I just make common denominator, so standard procedure, x minus 24, and then on the top I get 731 times x minus 24, and then plus 287x, that's equal to 2. Now this might look horrendous to you, but it's a paper 2, so I do have a calculator, which makes this a bit more bearable. So I'm going to expand the bracket on the bottom to get this. And then here I get 731x minus whatever this is, using my calculator. It is 17... Oh, what is it? 17544 and then plus 287x, and that's apparently equal to 2. And then here, what I'm going to do is I'm going to do 731 plus 287 to get 1018x minus 17544. And that's apparently equal to 2x squared minus 48x if I multiply this over. I'm going to, well, actually, I'm going to put everything on the other side because I'd like to work with a positive a term. So 2x squared minus 48 minus 1018 is equal to minus 1066 minus 1066x, and then plus 17544 equals 0. Now, I really can't be bothered, so I'm just going to use the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So here I get x equals 516, but I also need to check the negative value of it. So if I do that, what answer do I get? If I check the negative value, I get 17. Now I need to pick one, and I need to justify my answer. Now, I think this is the reason why they gave you the distance and the speed, because I think I was trying to cheese it, but now it's coming back to bite me because I need to somehow prove that this is right. How do I do that? How do I do that? About the flight lasted 2 hours. Um, I think. This is how. If we look at the time for here, if x equals 17, the time for this for second stage would be negative because you get 287 all over 17 minus 24, which is minus 7. Would be negative. Time can never be negative because I don't know. Well, it probably, I can't even lie to you, it probably can if you do some university physics. I have no idea what time is. Because time can never be negative, therefore, discard x equals 17. And then I can say, therefore, x is equal to 516, and that's my final answer. So I think that's the solution. A bit of a horrible question there, I can't lie. Okay, next. Iteration. So iteration is something that really rarely comes up. So I guess it's actually good to show you how to do this. What just happened? Okay, so we have this equals that. So all we need to do is to put in 7 into here to get R2. Because if R1 is 7, I put in 7 here, I'll get R2. So I'm just going to put into my calculator root 239 divided by 7. And that will give me R2. Hold on. I cannot use a calculator. Okay, so I get 5.84. So that will be my R2. And then finally, to find R3, you can just put in 5.84 into instead of your 7. And then you'll get the next solution. You get 6.4. And this is how you get R3. It's very stupid. I really don't like iteration because it's really dumb. And then finally, continue to the iteration to work it out. So here's what you're going to do. First of all, you're going to type in R1. So you're going to put 7 equals on your calculator. And when you do that, the answer button on your calculator is actually 7. Then what you're going to do is you're going to type in the square root of 239 all over answer on your calculator. And what that does is that it will actually keep repeating the iteration by using the new answer that you obtain. And then what you do is you spam your equal button until it doesn't change anymore. So if you spam it enough, you're going to get 6.21 to 2 decimal places. So so you're going to get 6.21, 2 decimal places for your final answer for 30B. Brilliant. Next. So x cubed plus 6 is translated 4 units to the right. Write down the new equation. Okay. So if it's 4 units to the right, we're going to do the counterintuitive thing, which is putting -4 here. And then cubed, and then plus 6. And if we expand that in here correctly, I will get the correct answer. If you're in top set, please use binomial expansion so you can revise further maths at the same time. But I'm going to do the normal way here, which is just to write it out. If you write out what cubed means, it means timesing together 4 times, right? So we get this, and now we're just going to do this very carefully to expand this open. So we get x squared, I'm going to put that in bracket, x squared minus 4x is minus 8x, and then plus 16. And then here I get x minus 4, and then plus 6. Then here I get x cubed, and then minus 4x squared, and then I get minus 8x squared, and I get plus 32x, and then here I get plus 16x, and then here I get minus 4 times 16 is 64, I think, and then plus 6 in the end. And then just very carefully collect your like terms. I get minus 12x squared, and I get plus 48x, and then here minus 64 plus 6 is minus 58. And that will be my final answer in the exact form they want. Brilliant. Okay, solve this. So first thing I can do is to do cross multiply, which means I multiply this up, multiply that up. So I get 5x squared plus 15 equals 8x squared, and then plus 2x, like this. And then I can just take away. So if I take away 5x squared, I get 3x squared. Take away 15, I get plus 2x minus 15. And that's equal to 0, apparently. And then the fact that it says 3 significant figures, I'm going to guess that it does not factorize. So I'm going to use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. I recommend you remembering this formula, but if you don't, then it is always on the equation sheet for you. So 3 significant figures is 1.93 for the first solution, and then for the second solution, do not forget it, is to put minus sign, and then you get minus 2.59. Minus 2.59. I'm going to say this is 3 sig fig. Cool. By the way, I would recommend writing a line about the quadratic formula. So you want to write out what the quadratic formula looks like before you put it into calculator to get all the working marks. But yeah. Ooh, some functions. So function is what a lot of people struggle on, so I'm going to hopefully help you with this. So first of all, we need to find the inverse function of f of x. So what we're going to do is we're going to set f of x equals y, and then we're going to swap the x and the y, and then we're going to rearrange for y again. So here y will be 2x, and then we can replace this with the inverse function. So f minus x minus 1x, which is inverse function, is 2x in this case. Brilliant. Next, we need to work out what g f x is. So g of x is a composite function. So first of all, basically what we're going to do is we're going to say this is equal to g of half x, because f of x is half x. So I'm going to replace that. And then I can just replace every single x that you see with half x. So I get half x minus half x, and then all squared, because that's the definition of g of x. So I can say g of x is equal to, just to simplify this, to make this a bit cleaner, x minus a quarter x squared. Now notice, you might think minus minus is positive, but the minus is outside of the bracket, so you're actually squaring this first. So you get this. So we're saying that 2x equals to g of x. So we're saying 2x equals half x minus a quarter x squared. What I'm going to do is I'm going to multiply both sides by 4. And the reason I'm going to multiply both sides by 4 is I can get rid of all of my fractions. Now I'm going to add x squared on both sides and then minus 2x on both sides. So I get plus 6x equal to 0. And then I can factorize this to be x times x plus 6 equals 0. And then I can just solve, which is x equals 0. Why did it become so small? X equals 0 or x equals minus 6, and that would be my two answers. And I guess it's worth noting that sometimes you want to check whether the x actually fits back into the function. In this case, you don't need to. Because I actually don't think they're allowed to do that in higher, but I'm not sure. Okay, more trigonometry. So cos x equals this times that, work out x, and x is acute. Okay, so cos x equals sine 60 is root 3 over 2, and then multiply that by tan 30. Tan 30 is 1 over root 3. So you might already see that actually root 3 and root 3 cancel, so I get what? A half. So when is cos x equals a half? Is when x equals 60 degrees. And that's it. Because it's acute, it must be less than 90. We don't need to find more solutions. And that's it. Next, more functions, so it's good practice here. So again, first of all, replace f of x with y. And then swap the x and the y. So you get this. Rearrange for y again, so I get x plus 1 equals 2y over 5. And then multiply by 5 to get 5x plus 5 equals 2y. Divide by 2, so I get 5x. I get 5x plus 5 over 2 equals y. Finally, replace the y with the inverse function. So you get this to be 5x plus 5 divided by 2. 5x plus 5 divided by 2. And let me just pull it back into the screen. Brilliant. So, to find f inverse of 3 is to just put in 3 into this function. This is a plus. So put in 3 into x, I get 15, plus 5 is 20, divided by 2 is 10. And to find f of minus 0.5, we just put in minus 0.5 into the original function, because that's f, not f inverse. So minus 0.5 times 2 is minus 1, minus 1 over 5, and then minus 1 over 5 minus 5 over 5 is minus 6 over 5. So when we add them together, well, minus 6 over 5 is minus 1.2. This is actually an instance where using decimal is actually more helpful. So I can say 10 minus 1.2 equals 8.8, and that's my final answer, because we're adding those two. And yeah, that's it. Next, show that the distance this person runs is less than 7.5 meters. Sorry, I cannot resist that. Okay, so to find the distance, what you do is that you integrate. Nope, that's a joke. You find the area under the curve. So to find the area under the curve, we're gonna go here to split it into a triangle. And then I will say this is a trapezium, and then this is a triangle. Now you might say, wait, hold on. This is a curve, it's not a triangle. And yes, but if we treat it as a triangle, we're going to be able to find an overestimate. And if we find an overestimate and it's still less, then I can show that the distance is definitely less. Okay, so first, a base times height divided by 2. So the area of the first triangle is 5 times 8, which is 40, divided by 2, which is 20. Next, for the trapezium is a plus b, the two parallel sides. So we have 8 plus 9, that is 17. Times the height, 5 to 9 is 4. And then divide by 2, so I'm going to say 17 times 2, which is 34. Finally here, we're going to treat that as a triangle. So we have 3 here. 3 times 9, which is 27. Divide by 2 is 13.5. So if we add this up, we get 67.5. And we can say, we need to explain this bit. So we can say because the area of this triangle. So basically, I guess what I'm going to do is I'm going to say R. I'm going to write R here. So I can, when I explain it, I can say triangle R. The area of the triangle R is an overestimate. Therefore, the entire distance calculated would be an overestimate. And then we can write, therefore, the actual distance Leo ran, Leo runs, because not Leon, I'm not running, I don't run. Leo, that is so sad. Leo runs, because it's in present tense, I'm going to answer in present tense, is less than 67.5 meters. I'm actually so cooked. Yeah, here you go. This is proof that maths drives you crazy. Okay, and then here, work out the value of w. So we have two variables. How delightful. So the area is this, and then we can find x, and then we can find w. Cool. So area equals half AB sine C. Half AB sine C, like this. So the area is 25 root 3, and that's equal to half, and then AB is 20x times 20x, and then sine C is sine 60. Okay, so this is not too bad, admittedly. So I can say this is 10x, so 25 root 3 equals to, root 3 equals to 10x. Sine 60 is root 3 over 2, so actually this becomes 5, and then I can multiply the root 3 here. So then I can divide both sides by 5 root 3, so I get x equals 5. So this length here is 5, which is very nice. Then we want to find this length, so I can, what do I use here? I use cosine rule here. Okay, so they're actually throwing everything at you in the final question, which is fair enough. It is the final question. So I'm going to say w squared equals 5 squared plus 20 squared minus 2ab, and then cos 60. Let me put that back into the screen for you guys, like this. Okay, so w squared equals, so 5 squared is 25, 20 squared is 400, minus, so this entire thing is what, 200, and then cos 60. And then we know that cos 60 is actually a half, I think, right? Yes, cos 60 is a half, so it's minus 100. Which means w squared is equal to 325. Yes. Which means w is equal to root 325. But we want it in the form a root b, so we need to simplify this. So this is equal to root 25 times root, what is this equal to? 13, I think. So this is 5 root 13. Like that. And that is in the exact form that they want. Brilliant! Next, exponential graph. So this is quite rare. I think that's why I picked this. So a lot of people, they just panic when they see an exponential graph. Don't worry, okay? Don't worry. All you need to do is put in your x and your y to find the full equation. So first of all, I can say 1 over 64 is my y is equal to k cubed because x is 3. So I can solve for cube, not solve for cubed. What does that even mean? Solve for k by cube rooting both sides. So if I cube root both sides, I get 4, because 4 times 4 times 4 is 64, is equals to k. So I can say the equation is y equals 1 over 4 to the power of x. To the power of x, like that. Technically speaking, I actually need brackets here because it's a fraction. Okay, like this. Brilliant. So this will be my full equation. Then finally, I need to show that 1/2 and 1/2 lies on the curve. So, okay, y is 1/2, and then I have my 1 over 4 here. And I'm raising it to the power of a half. I'm raising it to the power of a half again. So I need to show that this is equal. So I just need to show this is equal to a half. So the way I can do that is that, first of all, I know that 1/2 is equal to a square root. The power of a half is the square root. So like this, which means a half is equal to a half because we're squaring the top and the bottom. We do not break maths. This is great. And yeah, that's the question. Oops, that was way too fast. Okay, here, circles. Now, this is quite odd. I did not expect to see this in a GCSE, but whatever. life's life. And to be fair, it's quite far. It's quite long ago, so I don't think it's very likely to come up. So show that the x coordinates of point A and B satisfy this equation. So it's just a very complicated way of saying that. Go from here to here. And the way you can do this is that if x squared plus y squared equals 53, and y is 3x plus p, then surely I can just replace y with 3x plus p. Like this. And then I'm hoping that when I expand this out, I'll get the exact same thing that I want. So I have something squared, I get a squared plus 2ab, so I get 6px, and then plus b squared. And I'm going to minus 53 4 times 6, and that's equal to 0. I just move this to the other side. This is 10x squared, and then this is 6px, and then this is p squared, and then this is minus 53. That's equal to 0. That's the exact thing that is here, and I'm happy. Now the causes of A are 2, 7. Work out the causes of B. Okay, so, okay, let me think about this. Right. So we need to find P, right? So we definitely need to find P. Okay. So I guess I can find P by putting it in. So if I make a new equation, and instead of using this complicated equation, I'm going to try to cheese this question. I'm going to use this equation. So I know y equals 3x plus p. And if cos of p is 2, 7, I can just put in 7 here. And then I have 6 plus p, so p equals 1. So I get this. So I get, yeah. So if I rewrite this, p equals 1, the equation becomes 10x squared plus 6x plus 1 minus 53, so it's minus 52, equals 0. So I get this. Right, so I can solve for x by solving this quadratic, and then I can solve for y by putting it back in. Okay, cool. So if I divide by 2 on both sides to make my life a bit easier, so this divided by 2 is 26 equals 0. And I'm going to try to factorize this and just pray that this works. So I'm going to get this. So I must have 5x and x to get 5x squared, right? So to get to minus 26, does this factorize? Actually, is this, oh, it's paper 3, I don't care. Quadratic formula, cool. So, minus a minus b plus or minus the square root of b squared minus 4ac all over 2a. I get 2, and what else do I get? And I get minus 13 over 5. Minus 13 over 5. Now, you might notice that 2 is actually what we already got. We know that it's at 2, 7. So we already got that solution, so we can ignore that. So we're only working with this. X equals minus 13 over 5. So we know that y equals 3x plus 1. Remember, p is 1. So we can just put in a minus 13 over 5 like this, and then plus 1, and then we can find y. And if I type that into my calculator, because I really do not want to mess with whatever this is, this absolute monstrosity, 3 times minus 13 over 5, and then plus 1, gives me minus 34 over 5. So b is at x, which is minus 13 over 5, comma, minus 34 over 5. Absolutely horrendous. I don't know who made that question. I don't know why they can't make nice numbers, but that's it. Okay. Wait, June 2018. Oh yeah, we're from November to June. Show that this is an integer. Another question where please just remember your values. Cos that I did not remember. That is not correct. Cos 30 is root 3 over 2. I'm actually going. Okay, root 3 over 2, like that. Let me just make it bigger. We're timesing it by tan 60, which is root 3. And then we're adding sine 30, which is a half. So here, as you can see, root 3 times root 3 is just 3. So this is 3 over 2 plus 1 over 2, which is 4 over 2, which is 2. And it is an integer. Done. Easy. 3 marks. Okay, more function questions. Okay. So simplify this. So don't worry when you see some weird stuff in the function. Basically, whatever you see inside the function, replace the x with whatever you see inside the function. So here I get 5 minus 2x because I'm replacing x with 2x. Same idea here. I'm replacing x with x minus 1. So I get 3, x minus 1, and then plus 7, like that. So this will be equal to 5 minus 2x plus 3x minus 3 plus 7. So this will be equal to x, and then 5 minus 3 is 2, and then that's 9, and that's it. And then finally, solve g minus g inverse x equals 2x. Okay, so first of all, again, set it equal to y equals 2x plus 7. Swap the x and the y, so you get this like that, and then rearrange for y, so y equals x minus 7 over 3, like this. I'm going to put it up here so that you can see. And finally, you replace the y with the inverse function. So here we're working with the g function. So g inverse x equals x minus 7 all over 3. And we're solving that equals 2x. Okay, so x minus 7 all over 3. Hold on, that's not right, because I need to do that first. X minus 7 all over 3 equals 2x. Just multiply 3 on both sides to get this. Take away x on both sides to get that, and then divide by 5 to get this, and I think that is correct. Brilliant. Circles. So he has x coordinate 4, so I'm just going to make sure that I remember that. And then work out the equation of the tangent. Okay, so if I draw a line here, like this, this will be perpendicular because a radius meets a tangent at 90 degrees. And we also know that the equation of a circle is x squared plus y squared equals r squared. Just make this a bit bigger, which means in this case, 80 is equal to r squared because it's in the standard form, which means r is equal to the square root of 80. And I can simplify that because this is 16 times 5, so I get 4 root 5 here. Cool. So that's the radius. Now, I can work out the equation of the tangent by considering the gradient of this line. So if I draw this, so this length is 4, right? And I go down. This length, I don't know what this is, but I know the radius is 4 root 5. So if I do Pythagoras here, because this is a right angle, so if I do Pythagoras here, I can work out what the length going down is. So I get 4 root 5 squared, so all of this squared, and then minus 4 squared, which is 16, is equal to, I'm going to call this length, I don't know, A. I'm going to call this length A. So this is 16 times 5, which is 80. 80 minus 16 is 54. No, 64. And that's a squared, which is promising because that is a perfect square root. A equals 8. We don't need to say A equals plus or minus 8 because the length can never be minus. So I know this is 8. Here, this is 8. Now, why do I need to find this length? Because I want to find the gradient. Now, the gradient is the change of y over change of x. And here, the change of y is going down 8, so it's minus 8. And then over x, change in x, which is 4. And gradient is m, by the way, so I'm just going to use m. Gradient is this, which is equal to minus 2. Then, another thing that we know is that perpendicular gradients multiply to minus 1. Which means the other gradient, m of p, is equal to, now p is a point technically, tangent, is equal to a half, because a half times minus 2 gives me minus 1. So I can say y equals half x plus c, the y-intercept. Okay, let me move this up. So if I know this, and I know that it passed x equals 4, when y equals minus 8, I think. So I can find c. So, okay, so y equals minus 8 because I'm going down 8 here, and x equals to 4. So I get x equals 4, that's 2. So c equals minus 10, which means the equation of the tangent would be y equals half x minus 10. And that would be our equation for the tangent. Brilliant. I think we're on the final stretch here. We're very close to being done. We have some index laws here. So 81 to the power of minus 1 over 4. So when you have minus, you immediately put it to 1 over, and then the power goes down like this. And then what this does is that 81 to the power of 1/4 is the fourth root. I have no idea how to type fourth root, I can't lie. Okay, a fourth root is equal to a double square root, so I'm going to do that. Equals to 81, like that, boom. So this looks horrendous, but it's fine. So the square root of 81 is 9, so I get this. And then the square root of 9 is 3, so this is just equal to a third. Brilliant. Write 16 times 8 to the power of 2x as a power of 2 in terms of x, okay. So 16 is 2 to the 4, and then I can write 8 as 2 cubed. And then here I'm raising it to the power of 2x. Now, this is equal to 2 to the 4 multiplied by, what did I just do? It's multiply by. So here we can use the index law of multiplying in indices when they're raised to each other. So I get 2 to the power of 6x. And finally, when you're multiplying with the same base, this will be equal to adding the power because they're with the same base. So I get 2 to the power of 6x plus 4, and that will be my answer. Brilliant. We have some vectors here. So, hold on, what just happened? Okay, so here we have some vectors. So show that BCDE is a parallelogram. Okay, it definitely does not look like a parallelogram, but apparently it is. Okay, so to show that they are parallelograms, I want to show that they are parallel, obviously. And to show that they're parallel, I want to show that the vectors are a multiple of each other. So I know what D to E is, so I want to find C to B. So how do I find C to B? Well, first of all, I can find what B to E is. So here, B to E, I can go from B to E by going BA plus AE. So I can say B to E. I'm going to make it bold so that you know it's a vector. You should draw the arrow on top, but I don't know how to do that in PowerPoint. So in the real exam, draw the arrow on top. B to E is A plus 2B. This is A plus 2B. Technically, only the vector should be bolded. Like that. Then, what I can say is that if this is A plus 2B, I can find C to B by going against this and then going against this to find C to B. So C to B is equal to, going against this, I get minus B plus 2A, very important that you remember that minus gives you a positive. And then going against this as well, so I get minus A and then minus 2B, like that. So if I simplify that, CB, hello? CB, there we go, is equal to minus 3B, so A minus 3B is what I get. I'm going to stop bolding it, I'm not bothered. So CB is this. So because CB equals ED, I can say they are parallel. Because this is equal to that, therefore they are parallel. Now, I don't think that's enough because I only prove one side to be parallel. I also want to prove this and that to be parallel. So I guess I'm going to work out DC. Now, actually, I'm going to work out CD. So C to D, here, to go here to here, it's going against this and going against this. So I get minus B plus 2A, always be very careful. And then going against this is minus A plus 3B, again, be very careful. Which is equal to, what have I done? Which is equal to 2B plus A. Okay, so A plus 2B. And then, because b to e is a plus 2b, so I can say because, by the way, they don't have to be equal. As long as they're a multiple of each other, it's fine. But here the multiplier is 1 because they're equal. So because BE equals CD, therefore they are parallel. And then finally, we still need to write one more thing, which is because, hold on, because BE parallel, the symbol of parallel is actually is 2 forward slashes, but I can't do that here, so I'm just going to say and CD are parallel, and what else? CB and ED are parallel, and then I can finally write therefore. So I'm just trying to make sure that I get all the marks and show the examiner that I'm reasoning mathematically. And therefore, BCDE is a parallelogram. Parallelogram. There we go. And that's the answer for 3 marks. Quite a load for 3 marks, I can't lie. Okay, so we have a quadratic function here. Write down all the integer solutions to which this is greater than 0. So if we look at this entire function, when it's greater than 0, it's above the x-axis. So we're looking at this area here. So basically, what is greater than 0? That is an integer. So in this case, we have minus 3, that is inside this area. Minus 2, minus 1. 0 is an integer technically. I've no idea what just happened. So 0 is an integer technically, and then 1 is an integer, and then 2 is allowed because we have that little line here. It's greater or equal to, 2 is equal to, so this is allowed. So that is all of our solutions. Okay, frustum. So a frustum is basically, basically when you have a thing like this, that is a cone with a cone cut off, basically. So the volume of a cone is, basically, a volume of a pyramid is the base area times height divided by 3. So in this case, the base area is pi r squared h divided by 3. So the volume of the water will be the volume of the big cone, take away the volume of the small cone. So I can say volume equals a third times pi times r squared here is 25, and then times height, which is 15, and then take away the volume of this small cone, which is 1/3, times pi, and then times r squared. Now, r squared is the tricky part, right? So what is the radius of this little circle here? This r. So basically, if this is 9, then this must be 6, because the whole thing is 15. So 15 minus 9 is 6. So, if we look at the ratio between the heights, 15 to 6 is 5 to 2. Yes, it's 5 to 2, which means the radius will also be in the ratio of 5 to 2. So if this is 5, this must be 2. So this is how we can find that small radius. So if the radius is 2, radius squared is 4, and then the height is 6, as we established. We just need to work this out. Give the answer in terms of pi, which is great. So first of all here, 25 times 15, what on earth is that? 375? So we get 375 over 3 pi minus, so there's 24 over 3 pi. So this is 24 over 3 pi. And you might say, why don't you put it in as 8? Well, I don't want to put it as 8 because I can take away like that. So I get 351 over 3 pi like that. And I think this is divisible by 3. This is, yeah. So I get 117 pi. That's my final answer. Brilliant. Okay, so this one is just making it more difficult because it looks scary, but it's not that bad. So if h of x is the cube root of x, so h of x is the cube root of x. I don't know how to type cube root, so I'm going to type to the power of 1/3 because that's what cube root is. Then, if I set y equals that, there is a quicker method, but I'm just going to be very clear with my working for you guys to understand. swap them, so I get this. If I cube both sides, I can get rid of y. I mean, get rid of the power, which means h inverse is equals to x cubed. So here it's basically a very complicated way of saying sketch y equals x cubed between -2 and 2. So they gave you a grid, so you can actually just plot it, but I'm just going to show you how to draw that. So it looks like this, right? So a cubic looks like this. It passed through 0, 0. Something like that. Trust it passed through 0, 0. And then we have 1, 1. We have just tell them the coordinates. So you get 1, 1. You get 2, 8. And then you get -1, -1. And then you get -2, -8. I think that's it. Oh, and then show them it passed through 0, 0 as well. Cool. And then here, draw the composite function f g x. Okay, so f g x is just replacing everything you can see in replace the x with g of x, right? So this is sine of x plus 90 is what we're trying to find. So remember how when you have plus 90, you're actually going to the left of 90 degrees. So the normal sine graph looks like this. So if I move it left to 90 degrees, I actually get the cos graph because sine 90 is 1. So I actually just draw the cos graph between 0 and 360, and that's it. Brilliant. Final question here. We're finally done. Prove that this is always positive. So there's many, many ways you can do this, but I think the easiest way is to just complete the square. So I complete the square, I get x plus a half, or square. So remember, you always half the b term, minus what you get, because minus of what you get when you do this thing squared. So a half squared is a quarter, so I'm minusing it away. Plus 1, so I'm going to write my 1 as 4 over 4. So that's equal to x plus 1 over 2, all squared, and then this is plus 3 over 4. And then you can just say because. Now think about this. Because x plus a half all squared. Now, I don't care what x is. If this is positive, then a positive squared is positive. If this is a negative, then that squared will also be positive. So I can say because this is greater than 0 for all real values of x, therefore, I can say this entire thing plus 3 over 4, because 3 over 4 is positive as well, will also be positive. Will also, I'm just gonna write this for all real values of x. And then I guess I can just write another therefore statement, and I'm just gonna put it, put the original form back. This is greater than 0. What just happened? This is greater than 0 for all real values of x. If you're interested in learning more maths, you can actually say x for all real values of x. You can say for x and then epsilon and then real number, which I have no idea how to type here. Let me see. I just want to, if you, because I know some of you actually want to know how to do this. The way you can do this is by using symbol and then finding the double R one. I actually can't find it. Real number set. That doesn't work. Okay, basically it's a R, but the vertical line is two vertical lines, and you can say that as well. But yeah, thanks for watching. Hopefully that helped, and yeah, all the best with your revision.